All right. I think we should be good to go here, chat. Let's go ahead and make sure that we are, in fact, good to go. All right, we are. Very cool. Let me just make sure I have my comments up, and we will go ahead and get tonight started. First of all, I'm going to tell you right now, I do apologize. It has been a hot minute since I have done a video / live stream on here. I mean, technically, we have been posting some videos, but I mean, keep in mind, it's sort of been kind of all over the board. So thank you guys so much for your patience. It has been very busy with the business side of things. Is it off stream again? Let's see. There we go. I think I'm live. Hey, chat, can you let me know if I'm live? Anybody here that just is tuning in, just give me a thumbs up or a thumbs down. I think I should be good. It says I'm live. It says live stream offline. It says I'm live. Like I'm live. Okay. Well, we're going to go with it. And if something does appear in the chat, I will be reading for the chat. Okay, there we go. We're good. Things of working out kinks here. But anyway, guys, thank you so much for tuning in. This is going to be I posted on here a winter weather discussion, but technically this is going to be a little bit of everything. Severe weather we'll talk about for the Gulf Coast states as well as the South. And we'll also talk about the winter weather threat for the Northeast and New England. I want to just, first of all, as I was mentioning at the top of this video, I do want to apologize. I know I haven't been as frequent as posting content as here as I would have liked. As you guys know, I do run a business called Prestige Weather. It's a weather platform that provides weather consulting as well as weather content for various different mediums, direct to consumer, direct to business. So I've been really busy with that. Everything's going great, and I thank all of you for your continued support with that business. It certainly kept me busy. But I wanted to get this live stream out. I think what I'm going to do with the channel going forward, and I would love to get your thoughts on this, guys, so definitely leave a comment down below. I think what we'll do is I'm going to do live streams at least once a week, right? So I guess what I'll do is I'll shoot for Fridays, or if there's something really pressing, like the event we're expected to see over the weekend, then I might do another like impromptu live stream, kind of like what I'm doing right now. But I'm mostly going to stick to some live stream content just so we can talk weather. I can answer all your questions in kind of a laid back, sort of environment. So let's begin first. That all said, I mean, like I said, leave me a comment down below. If you want sort of that kind of format, let me know. It's really one of the only options that I have. I guess the other option would be that I just start recording videos and then putting those out maybe like once or twice a week. But I think that the live streams are a little bit more interactive than, say, just a typical video. So what I would like to do is sort of stick to that if we can. So let's actually, dive in. And again, leave a comment down below what your thoughts are on that. As you can tell, this is very impromptu. So let me go ahead and pull up College of DuPage, Meteorology, because the first thing that I want to do to start off tonight is show you sort of where we're at with our current jet pattern. So every website that we pull from is a public website that you can use, right? The beautiful thing about meteorology today is that everything is pretty much at your fingertips, right? Weather models, observational data, 7-day forecasts. I mean, you don't have to go on TV anymore. A lot of this stuff is available online, which is what makes it really cool to sort of interact with. But I think one of the issues that I found with meteorology is sort of along the lines of a lot of different sciences out there and a lot of different kind of technological topics, right? Which is we have a lot of information, which is a positive, but then the negative is we have a lot of information, right? What sources do you look at? What weather models do you turn to? I mean, there's so much information that we can pull from on a lot of these sites when it comes to weather. Where do you turn, right? What do you do? Where do you go? So what I like to do during these discussions, as you'll see, is I like to take a look at some of the sources that I pull from and, look at the different ways of interpreting the data or sort of going through the forecasting process. So let's go ahead and do that now, shall we? All the jargon aside, let's dive right into this video. So we got a couple things going on with this jet. It's a really fascinating setup here to really dive into. So we have an area or a ridge. So this is our 500 millibar. These red lines are indicating your jet stream. And so what we have right now in the lower 48 is a ridge, trough ridge pattern. So you got ridging out towards the west coast. You have a shortwave trough that's somewhat negatively tilted out towards the central United States. And then you have another area of ridging, also associated with high pressure, out in the east coast. With some convective shower activity, let's go ahead and kind of loop the radar here, quite a bit downstream of this surface low, which is currently positioned right over northern Minnesota. So we're seeing some areas of stratiform showers this evening across central Iowa. Some of that even extends as far west as, say, Kansas, and then all the way back towards Colorado. We are seeing some snowfall at our higher elevations, some additional powder for some of those ski resorts, especially by Breckenridge and to the west of Denver, especially by Colorado Springs and even Telluride to a degree. Out towards the southeast, you have an area of showers as well. A lot of that having to do with some Pacific flow that's continuing to cut through the southeast, so seeing some showers there. Not really much deep convection with these, as you can tell by your cloud tops. So we're mostly just seeing some showers out towards the southeast. And then, of course, up towards the north in places like Quebec and Ontario, we're also seeing a continuation of some showers. And again, no thunderstorm activity with these, not much in the way of deep convection. This system out in the Central Plains is really our biggest concern here, right? This is expected to continue to progress eastward. Meanwhile, this ridge that you see over the East Coast is also expected to progress eastward as well. So think of our jet stream as this conveyor belt, right? So our jet flow goes from west to east. And so, of course, if we have a ridge out here in the East Coast, then we would expect that to move off to the east as well and encompass the northern Atlantic. What you're going to see in the weather models tonight is what happens when you take that bulging ridge and that ample ridge and shift it east. Subsequently, what happens if I take my shortwave trough out in the Central Plains and also move it east? You're going to see that that ridge-trough interaction creates a pretty strong jet flow and a jet maxima. There's a lot of really fascinating things to dissect here tonight. So I think what we're going to do is we'll dive into the winter discussion first. And then on the second half, we'll talk about the severe weather threat for the Gulf. There's really two modes of hazardous weather, one of which being the winter weather and the other one being the severe weather. So let's get right into it. So again, this is our current pattern right now. And I guess what I'll do too is let me show you some other cool maps that I think would be relevant to the conversation. We'll look here at some of our upper air maps. And let's see here what I want to pull. Let's start first with a 500 millibar 12-hour delta. This is really cool, right? This is in real time. If you didn't even see our shortwave trough there as well as our ridges, well, now you can. So here, what you see when it comes down to your change, your height change, you have height rises out towards the east, height falls with our trough, and then height rises out west. So once again, we're talking about a ridge, trough, ridge orientation. That's significant because in meteorology, that's a progressive pattern, meaning that as that trough continues to move eastward, it's going to interact with that ridge downstream of it. And because what you'll find here in a moment with high pressure out in the Atlantic, that's actually going to help to create a pretty ample jet as well upstream. So this is a pretty pretty well established, synoptic setup when you have a ridge trough ridge, orientation there. And I didn't want to pull a sounding, but I did want to look here. Not vorticity. You know what I was looking for, guys? I was looking for the jet stream. I think that might have been under upper air maps. No, I guess it's not. Oh, RAP mesoanalysis. There we go. Sorry about that. RAP mesoanalysis. Okay, let's take a look at that. 500 millibar jet. So this is our trough, right? We have our strong jet flow that, as of the last, say, 24 hours, was cutting through the Pacific Northwest, right? As we flash forward to today, what you see is that trough really beginning to dig. Now you can clearly see a trough, that little trough there, right? You can see that pretty well now that it moves over the Rockies. And so right there is our trough axis. And actually, let me draw that here in black. Upstream, as we talked about, is our ridge, and then our secondary ridge out towards the Pacific Northwest. The other thing to note with this setup right now is, and how this is going to evolve here, Our area of low pressure, as we talked about at the top of the conversation, is going to be located out here in northern Minnesota. So it's somewhat downstream of this trough, as we would expect. But there really is two areas of troughing here. Believe it or not. Trough number one is somewhere within like this vicinity. So we have a negative tilted trough towards the north, and that's really where our surface low pressure is positioned. Meanwhile, out towards the west, we have an elongated trough that's a little bit more of a neutral tilt. Both of these troughing features are going to interact with each other at some point in this timeline, likely some point in the weekend. But it is important to note, as we dive deep into this discussion, there technically is two troughs. Trough number one and trough number two. And trough number two is sort of a neutral tilt, right? So this is not really promoting much in the way of severe weather, but we can get convection downstream of that trough, also known as our exit region. So we have been seeing some convective showers, maybe even a rumble of thunder in places like Missouri and Arkansas tonight. We've also seen those showers extend all the way into the southeast as well. So we sort of set the scene. Look, we've already established the jet stream, and part of the reason why I like to sort of start my conversations with sort of the boring stuff is because observations are important, right? I mean, we got to see what's happening now so that way we can project outward. If we just jump right into the models, right, we're not really doing ourselves a good service. Because who knows, maybe this jet stream is over here, right? Maybe it's already in the southeast, hypothetically speaking. And in that case, if it's already here, but the models are showing it out here, well then your models are really far behind the observational data. So that's why it's important to always look at your observations. And College of DuPage, wonderful website that does a really great job at all this different observational analysis that you can look at, to really dissect sort of what's going on with our pattern. And so that being said, let's head on over to WeatherBELL. Now let's look at the weather models. So we'll start first by the GFS ensemble. And like I mentioned before, we're going to really dive into the winter discussion first, and then we'll transition over to the severe weather. Let's start with our 200 millibar jet. This is our upper level jet. This is important because it helps us to identify Pacific flow as well as polar flow. So your polar jet and your Pacific jet. Well, right away, if I'm looking here, and this is 18Z Friday, well, GEFS, our ensemble, is doing a pretty good job. It picks up that troughing feature and then also that subtle shortwave that's negatively tilted out towards Minnesota and Iowa, as well as your two ridges. Now, the other thing to note is, speaking of Pacific and polar, if you were to diagnose those two, you would have your polar jet that's coming out of the Pacific Northwest, and then your Pacific flow in the upper levels that's moving from west to east. Now, this Pacific flow is really what's been responsible for the showers we're seeing in the Carolinas tonight. So I kind of mentioned that at the top of the conversation, but in case you're wondering, we do have quite a bit of specific flow, or it's not specific, Pacific flow that is moving through the Gulf Coast as well as the eastern seaboard tonight, especially the southeast. So that's going to come into play. Why that's important is because our polar jet and our Pacific, look what happens to our jet streak here. Look at that, right? We go from, say, let's even dial this back for a second. We go from about 78 knots in the upper level jet to right around about 115 to 126 knots. And that is because our Pacific jet is coupling with our polar jet. When those two jet streams couple, or when they converge, they produce a much stronger wind field aloft because of that thermal gradient, right? Think about where the air is coming from in the poles. It's colder, right? And the Pacific is warmer aloft. So those two, when they couple, that's going to create a really strong jet flow aloft. That's exactly what we're seeing here. So, if we're just talking about the upper level jet, folks, that is really strong. Unseasonably strong. So that's certainly something to watch, especially as we dive into the conversation of severe weather for portions of, say, Mississippi, Arkansas, Louisiana. More on that later. But as we take this even further, by the time we get to Sunday, look at how expansive that wind field is by the time we get to Sunday morning. Now it's encompassing a much larger area. Still within about 115 to, say, 100 and we'll even call it 25 knots. So still remaining pretty strong. And if we take that even further, look what happens here. Boom! Look at that jet, right? That's a huge change. You now go from 115 to 125 knots to, by the time you get to, say, Monday morning, early Monday morning, late Sunday night, that's like 150 plus knots of upper level flow. Why is that significant? Because when we have really strong winds aloft like that, that's a lot of forcing aloft, which is a telltale sign from a synoptic scale point of view that this system is going to be really strong. If you got a lot of forcing and a really strong thermal gradient and a temperature contrast and an air mass contrast, that's going to create a really strong wind field, and in turn, depending on where our trough sets up here, is going to bring about really strong upper level divergence, which then would promote surface level convergence. Really important stuff. Now, the 200 millibar jet, as I mentioned, is our upper level jet, but the other component here, and actually there's really a couple, we have to look here at the 500 as well. And so our 500 millibar jet, right, takes us all the way back. This is the latest GEFS run, 18Z. And as I mentioned, right, here's two troughing features, troughing number 1, troughing number 2. Right, sort of a neutral tilt down towards the Red River Valley, more of a negative tilt out towards the lower Great Lakes. As we get into Sunday, same situation is applicable here, right? Look what happens to your mid-level flow by the time you get to Sunday. Really strong stuff, right? And even much so because your troughing is pretty much at a negative bank. So that's telling us we got a lot of cold air advection wrapping behind it. And if we were to look at the low-level jet, likely some warm and moist air advection out ahead of our cold front. So strong winds to apply. Same thing with the mid-level jet. You're talking about anywhere, I mean, especially off the coast, once it gets into Maine, Nova Scotia, New Brunswick, by the time you get to Monday afternoon, you know, certainly looking at a jet flow of anywhere between, say, about 80 to 90 knots. So really strong. I mean, same thing applies. Now, as we get closer to the surface, right, we do expect our flow and our winds to not really be stronger than the winds aloft, because we also have to account for friction, the frictional force. Friction does tend to slow our wind down, especially as you get closer to the surface. The farther away from the surface, the less friction plays a role, to where it's pretty much just neglected, right? So that's our 500 millibar jet. Let's look at the 850, because I think that really tells the tale. And for that, let's head on over to the GFS. And by the way, if you have any questions, if you're joining us here on the live stream while it's happening, feel free to post those in the comments as we go through tonight's discussion. Also, if you're watching this video after the live stream has happened, go ahead and post your comments still, because what I'll do is, if you have any questions or you want to talk about the weather conditions or anything about your forecast, you can go ahead and post those in the comments even after this live stream is over, and I will be sure to answer as many as possible. Now, the cool thing about the 850, this is our low-level jet, so what it's indicating is essentially a low-level jet, if one does exist. Here's the crazy thing. Look at 6Z, right? So right here, by the time we get to late Sunday night, early Monday morning, well, a couple things to mention. First of all, what's off the page here is an area of high pressure. Remember, high pressure spins clockwise in the northern hemisphere. So that's helping to advect both warm air and moist air advection here from the Caribbean, right, and the South Central Atlantic. And so we certainly have a really strong low-level jet. How do we know? Well, because look at our wind field. We're talking, in this case, anywhere between 50 to 60 knots in the low levels. So you're kind of noticing a trend here, right? Even though we have really strong winds on all of our levels, from the low level to the jet stream to the upper levels, our winds technically are getting weaker as you get closer and closer to the surface. Keep in mind that our low-level jet is about 1 kilometer off the ground. But the interesting thing about this is not just the fact that we have a really strong low-level jet. We've already established that. But look at our front. You see that demarcation line? So watch your vectors here. Let's really draw this out and conceptualize this. So as we mentioned, we have southerly flow that's being convected northward. Also, we have cold air that's being convected south and east, right? And this demarcation line between really strong low-level winds and then backed winds is actually your cold front. Isn't that crazy? Look at that. That's literally your cold front. And this is one of those things where, I mean, even if you didn't know maybe how to diagnose the synoptic scale of meteorology, this really summarizes it all, folks. Not all the time do you see a cold front easily demarcated on a low-level jet map like that. What that tells me as a forecaster is this is going to be a really strong cold front. And not only that, but this is going to be a pretty strong low-pressure system. By the way, in case you're wondering where the low pressure is, it's not anywhere in the northeast New England. As a matter of fact, it's all the way up north into far reaches of Quebec, Nova Scotia, New Brunswick. It's way up there. And because of that low pressure displacement, your cold front really stretches. I mean, if I was to draw this out, this is what's incredible. If I was to draw out this cold front, look how far this thing extends. It is up and down the entire seaboard, all the way down into central Florida. That is your entire cold front. So that is a pretty strong frontal boundary, if you ask me. Especially if you can easily see it a kilometer off the ground. That's really well defined, really well sloped. That's certainly a sight to see. And so why is this important? Okay, we've already established a couple things already, right? We looked at the ensemble, which takes a general average of the different model solutions, and we discovered that we have really strong upper level winds by the time we get to Sunday, Monday. And same thing goes for the jet stream level, still in the mid to upper levels. We just talked about the low-level jet, and that's producing 50 to 60 knots of southerly flow. Not only that, but you have southerly flow, and you got backed winds. Right? Look at that. Isn't that crazy? I mean, it may not be crazy to you. I mean, granted, I went to school for this stuff. But the craziest thing is the fact that you can see that cold front easily demarcated there on your 850, on your low-level jet map, a kilometer off the ground. That tells us a lot about the strength of this system on so many different levels. I mean, there's really a lot of ways we can dissect this thing. So, yeah, anyway, I'm getting a little bit too excited. But it really is fascinating. By the way, I didn't really mention here, but these little arrows you see on the map, it might be somewhat hard to see here on the live stream, but those are actually streamlines. It even mentions it here on the map. These are streamlines. So it kind of shows you wind vectors and the pathing of wind about a kilometer off the ground. So the fact that we're seeing, again, this is wind out of the northwest, and then you have wind out of the south, and that's warm and moist air advection out ahead of what essentially is your cold front, which would be located right between that demarcation line of southerly flow and northwesterly flow behind it. So that's why, I mean, it's really important to look at these things because it does show the shear strength of the system. Now, the other reason why this is important is because, a lot of people are probably wondering, and I know I have commercial clients that they even ask questions like this about, what does this mean? Are we going to see a nor'easter? This is not a nor'easter system. This is not your standard nor'easter. Typically, when we talk about nor'easters, we're looking at low pressure that, is sort of, kind of lee side of the Carolinas and the Appalachians that sort of ejects northeast like that. Or the other case of a nor'easter, a typical one, would be along Pacific flow to where, say, a low pressure develops on the lee side of the Rockies, digs down in the Gulf, but then ejects out towards the northeast. That's your standard nor'easter. The problem has been over the last, I would say, month or so, in the first half of winter, is that we're not getting enough cold air advection here to where we're seeing this trough or any sort of nor'easter develop on the East Coast. It's because there's just not enough cold air advection to push colder air farther south into some of the higher populated areas in the northeast New England. So a lot of the activity that we've seen thus far this season has really been in, Maine, Vermont, New Hampshire, upstate New York. And that's been pretty much it. What makes this system different than a nor'easter and why it's not is because we're expected to see a pretty sharp cutoff here, right? So we have this cold front that we established. Much of the snowfall is likely, as you'll see, going to be, for New York and Vermont, New Hampshire. But those of you who are going to be getting rain out of this thing, expect to switch over to snow. I mean, think about how strong this cold front is. Play a drinking game on how many times I said strong during this discussion. It really is. So if you have a strong cold front, then you can make the argument that you have a very sharp demarcation between warmer temperatures out ahead and colder temperatures behind. We would expect to see snowfall on the back end, and you're going to see that here in a moment when it comes down to our model guidance with our radar. Okay. So a typical nor'easter is going to pretty much engulf the northeast New England with snow. That's not what's going to happen here. There's going to be certain locations that get snow and ones that will get snow, but maybe not as much as you think. So let's take a look at that here. I want to just sort of wrap this all in a bow because we've already spent quite a bit of time in the synoptic setup and the jet streams and talking about all that. And let's actually look here at just a precipitation map. And this is rather fascinating, guys. I think this goes all the way out. Let me go back to 18Z because it looks like 0Z is still rendering here. Perfect. So let's head on over to the northeast to start. And so we start and really begin Sunday. Remember how we talked about warm air advection? Well, that's going to lead to some convective showers, maybe even some thunderstorms, some rumbles of thunder in some of these cells. We even have some really nice convection, according to the NAM, firing off here in Long Island, and then that stretches all the way back towards Baltimore and even just east of the D.C. area, especially by Delaware. That takes us into what would be Sunday afternoon, and then as we get into the evening, then you start to see that snow begin to develop. This is exactly when we would expect to see our shortwave trough turn negatively tilted, right? And so when it takes on a negative tilt, so where our trough is sort of inverted like this, right? And here's our trough, we're getting cold air advection on the back end of that, and that's why our snow shield is setting up. We're also seeing our cold front develop here too. So as we go forward, let's see how far we can go with this thing. Probably not as far. So I guess we'll switch over to the NAM 12K in a second. But the one thing that I wanted to note, you can start to see your cold front. So this snow shield here, it really is a frontal boundary at this point. That is your cold front. And the other thing to note, we're getting a lot of rain out of this thing. Quite a bit, right? There are already flood watches out for Connecticut, pretty much a lot of New England tonight, because we are expected this constant southerly flow into this thing, and that brings a lot of moisture. You got a frontal boundary that sort of, takes a little bit of time to progress, and so we expect to see quite a bit of shower and thunderstorm activity for, Connecticut and Rhode Island, all the way back towards Massachusetts and even some portions of Vermont and Hampshire. A lot of areas under flood watch this night for that reason. But as I was mentioning, there's your frontal boundary, demarcating between snow as well as rain. There is also a freezing line, so some freezing precipitation and sleet. That's really going to be kind of a stretch. I think most of this is just going to simply be anywhere between rain and snow, and especially as we get into what would be Monday afternoon. So let me head on over, as promised, to the 12K. It goes on a little bit longer here. And here we go. That's actually 0Z. Let's go back to 18. And there we are. So take a look at that, right? So this system, look at that sharp transition, especially if you're in, say, the Catskills, or if you're in, Connecticut, especially northwestern Connecticut, far western parts of Massachusetts, Vermont, New Hampshire. Look at that sharp demarcation now. You are seeing, without even seeing the jet stream level, a really strong negative tilt in your trough axis. We already talked about at the very beginning of this live stream that at this point in time, by the time we get to Monday morning, we're seeing really strong upper level forcing with this thing. We really see our snowfall begin to ramp up. Southerly flow feeding into it, cold air advection on the backside, classic cold front setup and progression here. And as we go beyond Monday morning, look at that. We go from rain, heavy rain in Connecticut, to snow right then and there. And that lingers around for a little bit longer, could see some lake effect as well. So in trying to forecast snow totals for this thing, it really does present somewhat of a challenge because, you know, especially with the low pressure that's sort of wobbling around right now, it makes it quite difficult to see what areas are going to get the most snowfall and where. I mean, we can kind of establish that for the most part, looks like upstate New York, Vermont, New Hampshire are likely to get down to most of the snowfall, even back towards Maine. But my big question is, how far east does that snowfall extend, right? We just talked about the fact that we're expected to see this transition from rain to snow. So what does that mean for a place like Connecticut, and Rhode Island, and Long Island, New Jersey, for that matter, right? So let's look here at the snow totals. And the way I like to do this is, you know, sort of look at a couple of different models. There really is no such thing as looking at too many, so long as you narrow down to sort of a general spread. And so what I'll start with first, the GFS ensemble. We got to keep in mind there is a little bit of a cold bias to this thing, but before we dive into snow, it happened to pop up, so I guess we'll talk about it. Look at the heavy rain totals here. This is a general average, again, of 18 different solutions. We're talking about anywhere between, say, 2+ inches of rainfall, also including snow, right? This is just general precipitation from all the way in Bangor and Caribou, getting all the way back towards the Carolinas. Pretty strong stretch there of precipitation, and quite a bit of it. You know, again, we talked about this here just 5 minutes ago. We got flood watches out for the East Coast and much of the eastern seaboard with this system. But let's take a look here at the snowfall totals. And you might find my madness to my methodology rather interesting. So let's look here at the 10 to 1. This is taking a look here all the way through what would be essentially Tuesday. And so at the moment, it doesn't show a lot. It's rather interesting. Right? Not really seeing much here according to the ensemble. Let me also go ahead and look at the different product here. Rather than looking at the average of 10 to 1, let's actually look at something a little bit different. I just mentioned my method to my madness. Let's talk about it. So let's see here. We're going to head on over to the, not the probabilities of winter. I want to look here at the percentile. So this is really cool. We're going to look here at sort of the statistical side of our models, right? So what you're looking at here is the 50th percentile, meaning out of all of these 18 solutions we see here on the GEFS, what is the mean, right? What is the middle snowfall totals that we can expect, or the average, or the general average? Right now, at least as of tonight, it would take most of the snowfall anywhere, again, from upstate New York all the way back towards northern Maine. Now, keep in mind, this product's really cool that I'm about to show you. I've kind of dived into it now. But think of this as a statistical curve, okay? When I'm talking like 10th percentile, 75th percentile, 90th percentile, think about Statistics 101. So your standard bell curve, right? You guys have probably seen this in Business Class 101 as well. So out towards the left and the right portion of your bell curve, the left side is going to be your 10th percentile, right? As well as your 25th. The middle portion will be the 50th percentile. And then towards the right skew of your bell curve, you have the 75th percentile. That's a crappy 75th. There we go. 75th percentile, and then your 90th percentile towards the end. So in the case of the GEFS and the products we're about to go through, think of the 10th percentile as the most conservative case scenario when it comes to snowfall totals. Thereby, think of the right side of your bell curve, on the other hand, as being the most aggressive, or the worst case scenario. And then your 75th and 25th are sort of the kind of the middle point of those two. So let's go through that right now. Let's look at the 90th percentile, right? Worst case scenario, this is what it looks like. So at the moment with the GEFS showing anywhere between 6 to 7 inches for upstate New York, and then much of the snowfall being really confined to northern Maine, Vermont, New Hampshire. Fair enough, right? In the most conservative sense of the word, if we look at the 10th percentile, a whole bunch of nothing. So that tells you a lot about our snowfall spread just on the GEFS. You're essentially talking about from the 10th percentile being nothing to, say, 6 inches of snow. So why was that important that we just went over that? Well, I'm not trying to throw statistics like and throw it in your face and do math class all over again and give you PTSD. That's not the reason for it. The reason for me going over that is to just show you the sheer snowfall spread that exists in an ensemble like the GEFS tonight. 0 to 6 inches of snow in a place like upstate New York, way too much of a spread. So there certainly is a degree of uncertainty that we have to work through in this discussion, right? It's certainly the case. Brother, what's going on? Tyler, welcome to the stream. How are you, man? Thank you so much for tuning in. Appreciate you. Tyler, if you have any questions, post those down in the comments below. I'd be happy to answer those. And that goes for all of you here who are in the live stream that have any questions. So that's one ensemble. Let's take a look here at a couple others. The European ensemble. And we'll do the same exact exercise, right? 10th percentile, pretty much a whole bunch of nothing. 50th percentile, also somewhat a whole bunch of nothing. 90th percentile, a whole bunch of nothing, right? So, you know, Euro's being a little bit more conservative. It's pretty much showing a whole bunch of nothing here. Interesting, okay. Now let's look at the Canadian. Do the same exercise. 10th percentile, well, pretty much a whole bunch of nothing. 90th percentile, about 0.2 to 0.6. So far, from the ensemble point of view, we're only seeing the most aggressive being the GEFS, or the GFS ensemble, showing anywhere essentially between, say, 4 to 6 inches for upstate New York. There's one thing that I want to mention about these ensembles, and it's really important. These ensembles are at a certain grid spacing, meaning that this isn't high definition. Just got done doing my thing. Right on, man, Tyler. Well, welcome back. Thank you so much for tuning in. You know, these ensembles, they're great at giving us a general pattern, like we just diagnosed at the top of our conversation about the jet stream. That's great. As a matter of fact, it does wonders for that kind of thing. Measuring snowfall may not actually be the best tool for us. Because if we are only looking at things from a blurry definition or from a larger spatial scale, it may not do a really good job at showing where the intense snowfall rates will be. I'm going to tell you this right now, ladies and gentlemen. If you think that there is only going to be about 0.5, half an inch of snowfall in upstate New York out of this thing, I'm very skeptical about that. That's way too conservative. Now, measurable snowfall north of 4+ inches for a place like upstate New York, Vermont, New Hampshire, absolutely. But in order for us to really determine, what's happening here, or how do we determine our snowfall totals, again, the ensembles are great. And for a large-scale system, they actually do a pretty good job at handling it. But as you can tell, we still have a lot of spread here with our snow totals. So let's dive into some other model blends. In this case, we'll look at the NAM 3K. And I guess I shouldn't say model blends, more so convectivity allowing models, if we're being technical. Let's look here at the NAM 12K and see what it's outputting. So we'll do the exact same exercise. Now, remember, the NAM is not an ensemble. We can't do the statistical bell curve crap like we did with the ensembles. So we're mostly just looking at one solution here as opposed to, say, 18 to 20. Okay? But the difference is, remember, the NAM, the HER, the WRF, the NSSL, all of those different solutions are a little bit more, I guess you could say, high def, for a lack of a better term. So it helps to resolve some heavier bands of snowfall. Sometimes it can help to resolve, some snow totals as well in case there's sort of conflicting amounts that are being outputted. In this case, that's exactly what's happening. So let's dive into the NAM and see what that's saying as of tonight. Wow, what a difference that makes, right? I mean, my goodness, look at that. So now, let's just recap this. You had the Euro that was saying, remember, 0.2 to 0.3 in upstate New York. The NAM's showing 14 to 15. And even upwards of 17 to 18. When you have a really strong system like the one we just diagnosed on the ensembles, there's definitely going to be some heavier bands of snowfall. There's definitely going to be heavier rates of snowfall. I mean, let's think about this for a second. Let's just even look here at the 24-hour snowfall totals, right? So we'll even use, we'll just use Kuchera for this one. 24 hours. Look at that, right? So 6 to 9 hours, in a place like central New York, you go from, say, an inch to now, 7. That's like an inch and a half plus per hour you're talking about with that type of jump. I mean, that's just simple math right there, ladies and gentlemen. You're talking about, again, 1 to 2 inches, and then you jump right away to 6. You're talking about an inch and a half per hour. That's really intense snowfall, and that falls pretty quickly. So the NAM, in my personal opinion, is resolving that quite well. I would expect to see some pretty intense snowfall. It's not going to be something that only snows 0.3 inches, especially because, as we've talked about all stream, when you have really strong low-level jet southerly flow, and then you got also really nice northwesterly winds behind the cold front, then I would expect for a snowmaker to set up right between those two wind vectors in our low levels, right here, from, say, Pennsylvania all the way up through upstate New York and far northwestern reaches of Vermont. It's going to happen. Now, meanwhile, if you look at the NAM, and you really dissect this thing, it also shows some snowfall leaking into western portions of Massachusetts as well as Connecticut. You can thank that changeover, because what's happening there and what the models would suspect is that we would be essentially seeing a transition from rain to snow. So let's play this out again on the NAM. I think we did this at the very top of the conversation, but just wanted to show you again, just for the sake of conversation here. Let's see, composite reflectivity type, perfect. So as you can see, right, there's your heavy banding setting up. And you're going to expect that right there along that frontal boundary, that demarcation. Really nice snow banding, and then also some warmer advection with your rain, as we just mentioned as well. Northwesterly flow with the cold air, that backed wind behind the cold front, and you're going to get some really nice snowfall to set up. Even if you didn't want to go with the NAM, you can also look at some other solutions. You can also look at, say, the HERT, which actually I don't think we have a run for that. Let's try 0. I think we should. We do. Okay, so the HRRR does start to show, it doesn't go all the way as far out as I like, but it only does go out, say, 48 hours. What I will say is the HRRR is also showing that snow shield beginning to set up. I mean, once again, if you're not getting snow, you're still getting a crap ton of rainfall from that warm air advection regime. So definitely a lot going on here with this thing. And like I said, if you guys have any questions, post those in the comments below. And the other thing I'll look at, too, to sort of, I guess, end the conversation here as far as the winter part is concerned, is show you the NBM. Now, the NBM, for those of you who don't know, is the numerical blend of models. So it's showing you a general blend of basically every weather model under the sun. GFS, the Euro, the Canadian, all the convective allowing models, the HRRR, the NAM, the WRF, the NSSL. I mean, just think of as many as you can. It's probably under the NBM. So let's look at that too. It's rather interesting to also gain perspective on this too. And as you can see, this is interesting, right? So the NBM, we got to keep in mind something here. Remember how we just talked about the ensembles and the GFS and the Euro, and how they, with the ensembles especially, they sometimes can tend to underdo the snow totals? Well, let's remember something. We're combining the ensemble, the long-range guidance with the short-range guidance and blending it. So, interestingly enough, when you combine the two, according to the NBM tonight, it shows still the heaviest of snowfall corridor really aligning where that cold front demarcation would be, at least as of right now, which is anywhere between central Pennsylvania all the way up into far reaches of Vermont, New Hampshire. I will say one thing about the NBM, because remember, no model is perfect. If there's anything that I want you to take away from this conversation, is that there is, no model that is essentially 100%. There is no such thing as a silver bullet. Tyler, you asked, is this linked to our severe threat? Yes, which we'll talk about here in a second. This system definitely is. Same system, somewhat of the same setup, slightly different based on timing. We'll talk about that here in a moment. But the one thing I wanted to finish up on with the NBM before we do transition over to severe weather, because the NBM is blending those two types of solutions, it still may be underdoing the snow totals. While it's doing a better job at showing the average of everything, 6 to 8 inches in upstate New York may still be underdoing it. I will say, if you look at this, it still does resemble some pretty measurable snowfall here, right? It does correspond and correlate to where we are expecting to see snowfall as of tonight. But let's keep in mind something. Even with a range of 5 to 8 inches, this might be underdoing it. So there is the opportunity that the system could overperform what the model output is. We'll have to continue to monitor these trends, continue to watch the models, but at least as of tonight, the biggest concern that I have is really twofold with this system on the winter side of it. Concern number one is certainly some flooding concerns for the eastern seaboard from, say, Bangor, Maine, all the way back down into the coastal Carolinas. We could certainly see rainfall exceeding 2+ inches in some spots, and some locally higher amounts even. That's concern number one. Concern number two is if you're behind the cold front, which is really going to be demarcated like with this black line, I'm expecting to see snowfall. By the way, the one thing we didn't mention about the snowfall, an honorable mention, is that we are expecting to see some pretty strong winds behind the front. So if you are going to be getting snowfall, which we've mentioned you quite a bit during this live stream, anywhere between upstate New York and far reaches of New England, you also have the chance at some blowing snow that could reduce your visibilities. The combination of heavy snowfall rates, which as of right now I would say easily could be 1 inch to 1.5 inches per hour at times, along with strong winds sustained at 20 to 30 miles per hour, we could be talking about some local whiteout conditions. So definitely want to keep tabs on the weather and your local forecast, and the forecast here in the next couple of days, because certainly this could lead to some very significant travel disruptions all along, pretty much of New England as we go into this weekend and early next week. Whether you're talking about flooding or in this case snowfall, pretty dynamic system. It's going to certainly cause a lot of headache for many of you that are going to be traveling early next week, especially for the holiday shopping season that commenced a couple weeks ago that you guys are partaking in right now. All right, so Tyler, you requested it. Let's head on over to our severe weather threat. Kind of a different discussion. It's really going to top off the second half of our discussion tonight. And so I guess what I would like to do first, in your case, is look at the Storm Prediction Center. I am always somebody, I never shy away from the SPC. I think that their conversations and their thinking are always very insightful. Of course, there's some things that when I read through it, I might think, oh crap, I didn't think of that. Or a different conceptual way of looking at the environment for tomorrow that maybe I totally overlooked, right? So there's definitely value here. Like, I don't want any of you guys, it's easy for us meteorologists to be like we know everything, but we don't. One of the things that my professor always taught me is you never stop learning. You're always a student of meteorology. And so I try to apply that today, both in this video, this discussion, but also with my clients as well. Because as we have these conversations with each other, as we talk together about these events, we're all kind of learning together in a sense. We never stop learning, no matter how much you know about the weather. So this is a really great resource. I love the discussions they do. They certainly dive deep into the synopsis part. So let's kind of extrapolate a couple of things. I certainly don't want to go over every single detail in this video or in this discussion, but I certainly do want to highlight a couple of the things that pop out at me. So I talk about a deep, positively tilted upper level trough, which we already diagnosed, and then a trailing low amplitude shortwave trough will de-amplify as it moves from the southern Rockies towards the lower Mississippi Valley. And then they also mentioned there the cold front move across the southern plains and eventually into parts of the southeast. Now, it goes on to say for the eastern Texas and the Tennessee Valley, talking about mixed layer CAPE increasing into the 1,000 to 1,500 joules per kilogram range with more modest buoyancy, mill CAPE to near 500, potentially extending as far north as southern Kentucky. Meanwhile, though, we have deep layer flow and shear in advance of the approaching upper trough, which will support long photographs and increasingly favorable wind profiles for organized convection. So there's a couple things to just take from that paragraph. Let's talk about CAPE. I think a lot of us always think that CAPE needs to be 3,000 to 4,000, right? We need to have a lot of CAPE if we're going to get severe weather. Not true. Not true at all. So think back earlier on in the live stream. We spent a good 20 minutes talking about the jet stream. You know, the strong flow aloft, the low-level jet, all of that. That same point not only applied to the winter weather setup, but it also applies to the severe weather setup. That's what we call in meteorology kinematics. That's energy. Those are strong winds at different levels of our troposphere where our weather takes place. If we got strong winds aloft, if we got strong winds in the low-level jet, that is a lot of forcing, just like what we talked about. And that's also a lot of energy. And so all you need here is just enough potential energy to really channel some nice convection and robust severe weather activity. In the case of what the SPC is mentioning here, mixed layer CAPE, or the boundary layer, essentially, 1,000 to 1,500 is perfect, especially in a place like Arkansas, Louisiana, and Mississippi. It even goes on to mention, as we just highlighted, 500 joules per kilogram will extend as far north as southern Kentucky. Now, if you're in a place like southern Kentucky, which, at least as of tonight, is under a marginal risk, your severe weather threat will ultimately depend on how much CAPE you get. What we're going to find during this severe weather discussion is that we have all the ingredients necessary for some pretty robust activity on the order of producing tornadoes, right? A pretty tornadic, favorable environment. Except, not everybody's going to have enough CAPE to work with. And that's significant. Not enough CAPE means really not a lot in the way of a runway for some of these storms to go severe. So let's dive into this a little bit more. Surface-based thunderstorms are expected to increase in coverage, and this would be Saturday afternoon. We're going to have essentially our capping inversion eroded. Makes sense. Effective shear of 50 plus knots. We just talked about kinematics. Shear, right? The turning of the winds with height, 50 plus knots. That is perfect, right? That's what we want. Deep layer flow largely parallel to the front. Tendency towards a cluster and or linear mode is expected with time. It also goes on to say that large hail would be possible with any sustained supercells, and increasing low-level shear will be sufficient to support a tornado threat with any supercells that can be sustained from late afternoon into the evening, especially if a frontal wave can develop. Otherwise, damaging winds of possibly embedded brief tornadoes may become the primary threat. So, because, I mean, we even mentioned this in the winter weather discussion, we're still dealing with a really elongated cold front here. And so as cold fronts really progress eastward and they move rather quickly, especially with this setup, you're going to find that it doesn't really allow for much opportunity for supercell development. And the SPC highlights that with more of an emphasis on clustered convection, linear, quasi-linear convection. What that tells me, just reading from the discussion without pulling any maps, is that we're going to be looking at more of a linear convective mode. Right, so that's certainly what we're going to be dealing with here. So let's just kind of dive into it and take a look. And of course, you know, we'll be certainly looking at this more tomorrow, especially as we dive deeper into it. Maybe posting an update video tomorrow. But just wanted to show you tornado risk 5%, wind 15%, and then 15% as well for Mississippi, Tennessee, and Texas, eastern portions of Texas. So let's take a look at a couple of different models here, and I guess we'll call it a stream for tonight. And of course, thank you guys so much for tuning in and sticking around with me here tonight and talking about these things. It's very important. We got a lot going on. So let's head on over. Rather than the East Coast, let's transition back towards western parts of the United States, especially the central United States. And so we'll look here at, rather than the NBM, we'll once again look at the NAM. Now keep in mind the NAM has a little bit more of a linear bias. We got to keep that in mind here. But as we look at the composite reflectivity going into tomorrow, look at that, right? Got a lot of clustered convection, and we got some convection that kind of bubbles up here in our warm sector. We got to keep an eye on that. The NAM, keep in mind, it's a 12K. It may not be, it's resolving at a 12K grid spacing, or 12K resolution. And so, you know, we do have sort of this cluster convection here. That could be supercells. Because we're at a 12-kilometer grid spacing, it may not be resolving that very well. But as we, you know, get into Saturday night, you see much more of a linear mode. I would say for the time being, right, the big question, it's hard for us to really diagnose, you know, for tornadic development. Because I'm going to tell you right now, without even looking at a sounding, because I've already done that before the stream came on, we've already established, even from our SPC discussion, that we have really strong wind shear. And we have a really favorable kinematic environment for tornadoes. And I will be sure to look at a sounding here in a second and show you this. Even that we know that, storm mode's also critical too. And so as we get into, say, the late night hours, you see this become a lot more linear based all throughout, from, say, the Gulf Coast all the way up towards the Tennessee Valley. And that's significant because that means we're not seeing supercells at that point. It's just quasi-linear. And in this case, I think at some point, even if we're not seeing tornadic development, let's say it's not as widespread as we might have thought, the biggest threat here would then just be damaging winds. And we certainly are going to see some strong winds behind this cold front, especially as that continues to strengthen with its eastward progression. So let's take one last look, and we'll look here at, actually two different products. The first one's going to be severe weather. We'll look here at the surface cape, and then we'll also look at a sounding. So even on your cape profile, hey, do you remember that conversation we had about, cold front, warm front? Well, we can easily see a cold front and to some degree, technically a warm front, right? It's going to be, I guess you could say, here's your area of low pressure down here, and then you have a kind of a warm front and then a cold front set up, right? And there is your warm sector, pretty much anywhere you see that cape profile. And so we, at least on the NAM, just on this solution, have anywhere between, say, 1,800 to 2,000 joules per kilogram of cape. And that's quite a bit, right? That's quite a bit. Now, this is just one solution, and so, I want to keep that in mind. But you notice how that cape extends as far north as central Kentucky. So we could be seeing, definitely thunderstorms as far north as, say, Cincinnati by the time we get to what would be Saturday night. And then that cold front, look what happens, right? That thing rushes right in and chokes off any more additional, warm, moist air advection that comes out ahead of this thing, at least for the Gulf Coast. So that cold front rushes through, especially during the late night, and any storms prior to that eastward progression of the cold front that are supercellular or clustered at that time are eventually going to converge, grow upscale, and become more linear. So there really is a short porch here for supercellular development. Can it happen? Absolutely. And like I said, we'll look at a sounding here in a second. But the important thing is looking at the morning observations for tomorrow, because the critical thing with looking at morning obs is seeing what the environment is like in the morning. Are we seeing ongoing convection in the Gulf? Are we seeing a lot of cloud cover? Or is it clear? Those are important factors, because whatever happens tomorrow morning is really going to set the scene for our warm sector and our parameter space necessary to producing some pretty significant severe weather for places like Louisiana, Mississippi, Alabama. There's a lot to consider there. So even though we're looking at models, even though we're about to dive into a model sounding just off of the NAM solution itself, let's keep in mind two things. Number one, the NAM solution does tend to have a linear bias. And number two, even if we went with the NAM as our silver bullet, we still need to look at tomorrow morning's observations, because that's really going to, as I said, set the scene for what our severe weather setup will look like for the rest of the day, Saturday, and into the evening. Let's conclude tonight's conversation, at least with my part of the conversation, by looking here at a forecast sounding. So I'm actually going to pull one a little bit closer to where we expect to see most of the, thermodynamic environment, or the cape, to really be amplified. And so let's head on over here to our soundings. Again, this is courtesy of WeatherBELL, wonderful resource. It does cost money, but we really do like it here. A lot of great products on this page. And let's head on over down to Louisiana. And, I think what we'll do is let's just pull a sounding from Shreveport or Slidell. Slidell is usually a hotbed for severe weather, as we all know. And we'll also go to the NAM 3K. So let's take this all the way into Saturday morning, and then eventually into the evening hours. This purple line you see here, and let's actually back up a little bit. I don't want to get too crazy with the SKUT. I know there's a lot of exciting things to talk about with this thing. Let's sort of set the scene on the sounding. So down on the bottom, you have your temperature, right, in terms of Celsius. And then towards the left, or the y-axis, is your pressure. Now in this case, pressure in millibars is really just height. So 850 is about a kilometer. 500 is about 3, and the higher you go, and then eventually 200 to 100 is about 12 kilometers, 12 to 15. So we use pressure in this case as a reference level for height. And then, of course, the right side is your wind bars. That's really important. It shows the wind from the surface all the way up 12 kilometers high off the ground. So this purple line, as I was about to say, is your CAPE. This is your convective available potential energy. Your air parcel and really has a lot of energy to work with once it is, lifted, right? And that lift comes from our cold front, or in this case, a warm front. Either one, really. The cold front will really act as a forcing to lifting that parcel. And so it has a lot of CAPE to work with, right? Actually, pretty decent amount. I say a lot. I mean, we're talking here about anywhere, again, 1,800 to about 2,000, right? That's quite a bit. Don't underestimate that kind of CAPE. That's more than enough, as we talked about. Also, the important thing to note, too, look at your wind vectors. So you got southerly winds at the surface, and look how that bad boy turns. All right, we got clockwise turning, and also our winds really begin to grow stronger as we increase our height, because remember, we're decreasing the significance of frictional force in the winds, so we're actually getting our winds to strengthen, and also the thermal gradient is greater aloft. So we see some really strong winds above 500 millibars, above 3 kilometers off the ground. A lot of force. Right? We talked about that. All stream, different aspects. Lapse rates, 6.7 Celsius per kilometer, 6.2 Celsius per kilometer. Hey, there's quite a bit of cooling with height here too. Some pretty appreciable lapse rates here. So look, I mean, for a case like Slidell Airport, this is definitely a pretty decent sounding. We have veering here, but one thing that I will say is our veering at the surface, even though we have turning of the winds, it's not as strong. Like, think about that for a moment. We don't really have strong southerly flow here. And also our helicity is kind of crap. And remember, helicity is the corkscrew motion of our updraft. So you usually want to see these values, say between, 180, at least greater than 180. And we're not seeing that here. So for Slidell, at least based on this sounding, certainly expecting severe weather. Just a low chance of a tornado based on the veering. But I'm a little bit particularly concerned about the southerly flow because it doesn't seem as strong. I will say, 850 though, not bad. It's actually really not that bad. I was expecting a little bit more out of this sounding, but I guess the tornado threat, if I remember correctly, is a little bit more towards the north in places like northern Louisiana, Mississippi, Arkansas area. But certainly something to watch. Areas that have the strongest low-level winds, along with that CAPE that we just mentioned here for Slidell, you guys are going to have the best chance at severe weather for sure, especially early on in that warm sector. My concern right now, depending on the morning obs, is what happens with that warm sector. Because if it's not cluttered with just backwash shower convection or southerly garbage, and it's got, some pockets of diurnal heating, getting down to the surface, then we're having a conversation about potentially some discrete to semi-discrete supercells. It's in the right environment for it. Again, the Slidell sounding, maybe not the best example. I guess the other one we could look at would be, Shreveport, technically. Let's see. Sunday night, there's a bit of an inversion there. Yeah, that's very stream-wise. Yeah, interesting. Okay, so that's fascinating, guys. This is also the Shreveport sounding that I pulled. CAPE profile, a little bit more stronger. I shouldn't say a lot stronger. I mean, we're talking about most unstable here, 2,134 out of Shreveport, and this would take us into Saturday afternoon. Look at our HODO, though. I mean, we have veering kind of throughout, right? But whenever we're looking for supercell development, we should be looking for a really strong, wind vector that corresponds with, say, 1,800. And this hodograph is kind of doing a curlicue like that. You got really strong winds aloft, but the problem, at least on the NAM, is you're not really seeing much in the way of a strong low-level presence. The veering is there, but the strength of that veering is not. So let's look at this from a different perspective. Maybe the HRRR might be a little bit more aggressive with the veering here, at least in the low levels. Let's see for a second. This is Saturday. This will be tonight. Let's go back here to 0. And again, we are looking at this in real time. And let's see. It looks like, by the HRRR perspective, that it wants initiation a little bit, I guess you could say, earlier on in the day. I mean, the concerning thing is, if I look here at, again, this is Shreveport, but looking at the HRRR perspective, what's interesting with this sounding that's popping out at me right away is the fact that, you know, it's somewhat, I mean, on the same page with the Cape, pretty much on par with it. But what's interesting is that you get a lot of, I mean, this profile, guys, you get a lot of dry air here in the mid-levels, but then at the surface, you're pretty much, your LCL is down towards the ground, meaning that you're getting precipitation in the low levels. So what I'm seeing from this, at least as of one of the latest runs, is kind of a different output. We have stronger low-level veering on the HRRR, which I would kind of expect, because again, the NAM may not be picking up well on the veering if we're trying to diagnose for the chance of supercells, like in a small sort of corridor. But besides the fact that the HRRR is showing stronger veering, the other interesting thing that, again, pops out at me, one of the things, is that it looks like it shows earlier initiation. And we can look here at a reflectivity map in a second. The other thing that I wanted to point out, look at your lapse rates, much stronger, 7.6, 7.4. So while the NAM was showing lapse rates and cooling with height of that air parcel being between, say, 6 to 6.3, you have the model like the HRRR being a little bit more aggressive on the lapse rates. Also a little bit more aggressive on the low-level veering, which, to be honest with you, can't say I'm that surprised. And I would actually expect to see a little bit of a stronger low-level veering tomorrow, considering the forcing of this system, especially as it takes on more of that negative tilt trough axis, that negative tilt orientation, by the time we do get to Saturday night. But again, my concern here is that we may be seeing precipitation early on in the event to where it could sort of eat up on some of the energy later on in the day. And I think even that's shown by our Cape profile here. Yeah, look at that. Pretty much goes away by the time we get to Saturday night. We lose that energy pretty quickly, and our cold front, as you can see, is pretty much demarcated by your wind barbs because all your flow becomes backed at that point. So let's take a look here at the reflectivity of both of these setups and see if we're right and make sure that we've diagnosed this correctly. I always like to do this just to check my work, right? It's like in math class, you want to make sure your answer's right, so you go back and you check it. And then you find out you're wrong still. That's the crappiest feeling in the world. So let's zoom in here a little bit closer. And we'll head on over towards the Gulf. I think you could say it's the Deep South. That's fine. And we will look here just at the reflectivity type and precipitation output. This takes us into Saturday morning, right? You got some shower activity forming here on the NAM 3K with some convection ongoing for northern Mississippi. Hey, that's something to keep in mind, right? If we got a lot of convection already going this early on, that could eat away at our setup. But that also could mean that we're getting severe weather initiation earlier in the day as opposed to later. So we got to keep that in mind. I mean, this right here could be a discrete cell, right? Could be. So as we go from the morning into the afternoon, right, we'll head on over to the afternoon, we see those shower activity continue. Additional development out ahead, right, in places like East Central Mississippi, Alabama, and then here's your line. That's pretty much your cold front. And any additional warm sector cells would form, early on Sunday morning, and that's going to be mostly confined to the Panhandle. Maybe some water wedgies that could move on shore. We'll see. That depends. But once you see that line, of course, like I said, that's all frontal at that point. Mostly going to be just some damaging winds as the main threat as we go into late Saturday night into Sunday morning. Now, the HRRR perspective on this, let's take a look at that in the 3K as well. We'll head on back to the 0Z, which is what we looked at. And hey, what do you know, right? So we looked at Shreveport. Well, Shreveport's going to be, sort of back in this area, right? I believe. Yes, somewhere within that area, if I'm not mistaken. But either way, we have quite a bit of shower activity that's taking place in northern Louisiana, right? So those showers are taking place. We got some convection on the back end, especially towards Arkansas, and that's also taking place as well, and even back towards western Tennessee, central Mississippi, northern Alabama. So that's definitely ongoing, right? And we see that convection really taking shape as we get into Saturday afternoon and evening, and then there's our cold front as we talked about before. Maybe another band of showers and storms behind it, but that really remains to be seen. So otherwise, I'm going to stick around here. Hey, if you guys have any questions, let me know. I'll stick around here for another minute. I did a lot of the talking tonight, and I appreciate every single one of you for joining the live stream, but like I said, I'll give it about another minute or so for any questions on the live stream. If you're watching this video later, watching this, say, in the middle of the night tonight or tomorrow morning as you head out the door, if you have any questions about the latest with the severe weather setup, the winter weather setup, post those down in the comments below. Even though you didn't join us in the live stream and you're watching the archive version of this video, still post your questions. I'm happy to answer those. I'm not charging you for it, right? It's totally free. I'm happy to do it. Happy to give you some information there to make you weather aware. And yeah, so anyway, seeing that there's no questions, Tyler says, thank you, I learned a lot. I'm glad, Tyler. Thank you so much for tuning in, my friend. I'll be sure to talk to you soon here. And for the rest of you that have joined tonight periodically throughout, thank you so much for tuning in. Really do appreciate your support. Thank you for getting us to 86 subscribers. I've seen quite a few people subscribe here, even when I haven't been posting content, and I greatly appreciate that. So thank you guys so much for tuning in, and we will see you on the next weather video. Take care. Bye-bye.